ended up focusing on was the one that had more material under the pile than on top of the pile, and it was more or less of a guess at that point, but going through the details, this is the system with the 4 legs. There was one point, this specific elevation, so looking over here, that was approximately at mid-height, and looking at the failure of these diagonals, I was able to say they all failed in tension. There wasn't any, a lot of these tubes were kinked, or the connection here to the gusset plate, or the legs in that case, they didn't really have gusset plates. It was to the leg, but it was compressed this way, bent this way. So that tends to be, not an initiator because it doesn't really create a separation. Pulling it out creates the separation. So being able to say FT, so that's in tension, 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 tension all around. And you break on one side, the other side now is just free to move. It's going to bend and do whatever. So we essentially found there was one point where the whole section, the whole tower started expanding. Without documenting, and all these pieces were all over the place. Exactly where it started, this initiation is where one piece was about 100 feet from the other. So the only way we were able to do this is we had a team taking a bunch of notes, labeling each node and figuring out what was the failure mode. Was it a tension, a compression, a bending up or down? Because after it opened up, then we had a lot of shear. It's 4 planes with diagonals, so there were 2 of them that just moved as wall, and you lost everything in between. And the next step where the big legs started to buckle, because now you didn't have any support. But essentially, it was looking at each individual connection, and that's one here with this tube to the angle corner. So this is the equivalent of your gusset plate. It's welded all around. It broke exactly where we would predict it will break. It's not the initiator because it's still connected, but it's just an example for you to look at. This is one that was completely broken and in tension. Now, this photo was taken hours, maybe 48 hours, but something like that after the collapse, and they don't have rain over there. When you see that rust, it was already cracked way before the incident. It's not something that happened on the day of the incident. So when you have this cracked over here, did it extend that way becomes a question. Was it cracked also on the other side? And that's where you start thinking about a tube. Oh, this tube should be able to take 5,000 pounds of tension, to something like, well, maybe it only took 800 pounds to break it, something like that. It's very unfortunate. At the same time, it's a lesson in terms of receiving inspection. If they ask me to look at this whole crane when they got it, these are the kind of things to look for. It's painted, it looks nice, but this whole surface is pitted. It's inside the tube, so there was a lot of damage to the steel before it even got to the site. And it's if you want to see what the government says about it, these are very there's some public information about this, and it's normally the case, but it's unfortunate that people just they have a project, they say, okay, well, we used this crane before, so let's get a fabricator to repair it. They had some repair welds, they had patches, all sorts of things, and nobody went back and say, well, is this going to be strong enough? And that was part of the problem. The regulation for this type of system, because it wasn't for people, it was for material, is just not exactly as strict as if it was for workers. Nevertheless, they were moving workers on it sometime, using the excuse that it was safer than having them crawl around over the arch. So at the end, you do wonder, okay, why are they allowed to be almost unregulated here? It's a very high risk structure. The example that I'm going to start, before I go to this piece, let's do this very briefly. This is a big shaft for a wheel. I think it was on a train, and the reason I'm bringing it is just to show you what you can learn by just looking at a fracture. It is a complex fracture, right? It's not like pulling a specimen on a tensile machine. And what happened is there were multiple initiations. There's a crack that started right over here, and there was another crack that started on the very opposite side, and they pretty much met somewhere in the middle. You can see beach marks when you see these lines. This is where the crack was at a certain point in time. All of this was already cracked. Up to the point where, to tell you the truth, this is the only thing you had left at the time of the failure. When we see those, it's a very easy, you don't even need fracture mechanics to say the load was not that high. This is not a problem with load. This is a problem with fatigue, which starting crack around the circumference and a lot of cycles going around turning to grow these cracks. A lot of times, and that's what happened in elevators as well, there'll be, the bearing starts to move. It's supposed to be press fit, and you're supposed to have the movement, be taken care by the rollers or the balls. But if the race starts to move against the shaft, you create gouging, and that's what initiates these fatigue cracks. So even though this is designed with factor of, I would say, 15 against the static bending maximum load, it still failed in service. The two terms, there are only two terms in terms of looking at those fracture surfaces. One are crack propagation lines, and you see them, if the initiation is right here, you see a step right here, and it's sort of radiating. There's another step here. These point towards the initiation. Essentially, you start somewhere and it's spreading. So if you look right here, you see these little lines. So you had multiple initiation sites. One crack started here, one crack started there, just at slightly different height, and they were all going that way. And you can see here that when it started going this way. This is the local direction. So if I'm looking in this area under the microscope, I know if I'm looking for initiation, I have to go that way. It's less obvious over here, but it's the same right here. You see this one, you see this one, you see this one at an angle. So this is where it started. It's one of the initiation. There are multiple. There's another one right here. So now we found a third initiation site. Crack propagation line, this big step right here, tells me over here the crack was going that way. And then the crack arrest line, all these beach marks. So when I say beach marks, it's the same as the crack arrest line. It's where the crack was at a certain point in time. I'll put it somewhere. Just be careful. You guys are smart. There you go. Crack propagation line, these big steps over here tell me it all started in this area, and there's another step here, so there was another initiation right there, for example. And at some point in time, the crack was just going exactly along these little lines there. So at this point, we've identified at least 3 initiation sites. If we kept looking, maybe we'll find more. What does it mean? Well, it means it wasn't that hard to start a crack. If it started at 3 locations, they were competing to reach the center, so there wasn't just one problem with this system. I'm gonna run out of time here. Let's see. I can do one more, and then we'll close it there. This is the stem portion of an intake valve. So if you're looking, it's a 6-inline Volvo diesel engine. You got these 2 different valves here. One is the exhaust and one is the intake. So they all open at a different point in time. And the combustion chamber is just being removed here. The cylinder is out to be able to see what's going on. It failed essentially at the junction between the valve head. So if I take it here, this is sort of how it was located, more or less. And it's completely out at this point. This was not obviously the biggest loss. The reason I'm mentioning it is I was talking about crack propagation line. It allowed me to determine what happened. So if you look at this one, it's the same story where there's a lot of fatigue, and the final fracture is that little corner over there. This is the only thing that was left at the time of losing the valve cap. This part here is the final fracture. Let's pass it around, just keep a look at it. So I can see, that's a good thing, you can see ahead, because sometimes I talk ahead. When you have the notes, you can see ahead. It was dirty. When I'm looking at this, I was thinking already, oh, maybe this is my final crack RS line, and what is on top is the final fracture, but I couldn't say for sure. So when I was talking about documentation, one of the first things I said was, I need to image this before I clean it up. This was the condition of the deposits, then I put it in an ultrasonic bath with some mild detergent, and I got to this point. It's still not exactly clean, but at least I was able to look at the fracture surface and make my interpretation. So final fracture, there's this line here. This is when you reach the fracture toughness. There was only so much material left, very little. Okay? And looking on the other side, I have this beach mark here. So this is one area where the crack started. I have another beach mark here. Oh, it started here too. And then this is harder to see from here, but I kind of knew there was an initiation site there too. Another situation with 3 initiation sites. I'm looking higher resolution under the microscope on one side. Yeah, these are my crack propagation lines right here. 1, 2, there's so many of them, and they're all pointing to this area. This is where the crack started. Am I able to see something there? Nah. So we're going to look at another crack initiation site. This is where I get interested, because what's this? A hole. It's out of focus under the microscope, so there's just nothing here. And what I can say is the crack started here, 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 here. These are all initiation sites, because this is where I have my crack propagation line starting to diverge from each other. So it means that I had this hole before the crack started. This is not a corrosion pit that happened after starting the crack. I formed the corrosion pit, and then I started the crack, which means at some point the engine is 25 years old. My guess is for 5 years it hasn't been used, and it started corroding. I had all these pits, and you can see it on the side of the shaft. There's a lot of pitting. These pits happened before the crack initiation. Everything was fine up until I started pitting that shaft, and that caused the progressive damage, and then a couple of years later it failed. So that was the lesson learned from that one. And so our next lecture, the two for us, is Monday. Tomorrow Professor Eger will be here to talk about welding. Thank you.